In this project, we're going to look at using Tilemaps for our artwork inside the Phaser game. We will learn about using Tiled to help generate the tile maps and tile sets to write the JSON and integrate that into the Phaser game engine. But before we do that, it's time for a little bit of housekeeping. So right now we have a shell project that we will be able to recycle with a few additions to it that were not in previous projects. So with it, I have added a little style line to set the main page background color to a dark gray, and that color could be anything, but right now I'll just leave it as dark gray. It looks better than the default white. I've also added in a div with an ID of the game. And we will be using these moving forward because we're setting it up in the shell so that we will take advantage of the scale manager that is built into Phaser, so it will scale our projects to fit inside the target window, so in the viewport. We could handle that scaling through CSS and write some complicated CSS, some JavaScript, and some other things to go with it, or we can just let Phaser Scale Manager take care of it for us. One of the things it likes to have when we do that is to know the parent that corresponds to that ID, the game, that is that div. So the game is being loaded into the parent. So this is something new that we're doing. Now, if we remove this information and look at the project, we will see the project sits in the corner right now because the project is sized to 300 by 240 pixels. Now, if I let the scale manager work, then it's going to scale it up to fill the available viewport. So it will take our artwork and scale it up. Now, another addition that we've added this time is going to be pixel art true. And we do that because the artwork we're working with in this particular project is pixel art. And when it scales up, and if we don't have that line in there, it looks fuzzy. It comes out a little bit junky. So if we want it to be crisp, so we see crisp, clean edges with no anti-aliasing, then it gives us a better result. So those are a few of the things we've done. Otherwise, we have our game scene, which I've set a background color. That's that purple we see. I'm leaving in cursors into it because we're going to be using that in most of our projects. We might as well leave that stubbed into it so we don't have to rewrite it every time. And inside the update, we will look for movement information, and we're separating the movement information from the animations because we will code them a little bit differently. And then I have my title scene, win scene, and lose scene stubbed out, waiting for content to be put into them. So you could go grab content from a previous project and populate it, but we will leave them empty for now. And you will notice we're immediately loading the game scene. We're not going from title to game. And during development, that does speed up the process, making it a little bit easier. So these are some of the changes, the updates that we've put into the core shell game. And moving forward, we'll be able to reuse this multiple times. Now, I'm going to modify which script I'm looking for, and this time I will look for Mario, and we're going to start fleshing that out. And currently Mario is at this point the same as what we have inside the shell because we haven't added any new content to it. So I can close the shell so we don't need to look at that. And this is the Mario graphic that we're going to be looking at. This is a tile sheet or a tile set, so we can see the different tiles. I guess this would be the tile set because this is now the information that is used to construct the Mario universe. So we can take all of this information and look at how to put that into a Phaser project. To add the Mario into the project, we of course need to load the file as part of it. So inside our preload, this dot load dot, not preload, load dot image, and the image we are going to do will be our Mario, and it is in my assets, and it's Mario PNG. So that now loads it. To verify that this is working, we can simply say this dot add dot image, and now let's see, how big is our project at the moment? It is 300 by 240, so we'll go 150, 120, Mario, and once we have done that, we can hit save and see that it loads it and scales it up. Now let's just try a couple things here. So if we turn that off and save, now if I look at this, we can see how by not having pixel art on, we have this anti-aliasing occurring, which tries to smooth things out, and well, it looks fuzzy. And that's not good. So let's put pixel art back on. And now when I look, I can see how it's crisp and clean. And that is what I want when I am scaling up pixel art. Now, if we turn off the scaling and see what happens, then when we go here, we can see, well, that's how big the project is. So that's the actual size of the pixels as they show up in the browser window. And this is why we're using Scale Manager, so that our artwork can populate the page. So that gives us a better option. So this is one way we could work with it, but we're not actually using the asset as a sprite sheet yet, or a tile map, or a tile set with a tile map. So now it is time to put that in. So as we go to put it in, the thing to keep in mind is each square here, which is a 16 pixel square, has a value to it, or a position. This is 0, where we start at 0, 0, 1, 2, 3, 4, 5, etc., etc. So we can now use those numbers as a way to be able to display those images into the project. And the way that we are going to be able to do it is we need to set up a couple values here. So we need to create a map that will store our tile map. Then we need to add our tile set image, and then we need to create a layer from that tile set. So we need to use that or create that data. So one way is we can hard code the level. So we hard code this level, and it's an array. So we use square bracket notation on this, and this array is going to be simply a series of values. So we could do something like 0, comma, and because it's double digits, it's not a bad idea when we're doing it to make it easier to see what we're doing. So I'm going to have a whole row of zeros across the top to form a brick layer. Now, if we go back into the image, we can see we could even alternate 0, 1, 0, 1, 0, 1 if we wanted. And we'll just do that for now, just for kicks. 0, 1, 0, 1, 0, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that gives us one row. Now, as we set up a row, so we see how we can now align these numbers. So after entering some random numbers in, so we have our level defined. So we'll notice as we go through the level, the key thing is as we have each row here. So this is what is technically a two-dimensional array. So each row is an array element. Thus there's a comma after it. But this final comma here, if we leave it in, it will cause an error. They are working on the JavaScript specification so that when we have a multidimensional array, the last element in it, it will just ignore the comma if you leave it there. But right now, if I have that comma after the last item in the list, then it does fail. So we don't want to do it that way. It'd be the same way though if you wrote out a list of items. You don't put a comma after the last one. You just put commas between all the items. So each chunk here, each row is an array. And then this whole thing is an array. So it's a collection of arrays. But when we arrange it spaced out in a grid like this, it allows us to be able to see what each item is. So we can almost start to see it matrix style of what is the artwork that is there. So the first thing is we need our level data. And doing it this way by hand is very difficult. It's not something that a lot of people want to do. And if you have a really complex world, it sucks. And that's why we'll look at using the program Tiled, which will allow us to do this much easier. Now that we have the level data, we want to make our map. Now you'll notice that we're not creating variables using this and we're doing constants because these are things that are not going to change during the duration of our program, so we can just let them be. So this dot make tilemap. Now tilemap is all lowercase, and then we need to specify the key value pairs we're putting in here. So we say data, and then the data we will use is our level that we just created. And then we need our tile width, and that tile width will be 16. And our tile height will also be 16. So when we do this, the tile map is a data object. It's not a display object. So it's not something we're going to see, but we're using it to store the data. So this takes this two-dimensional array and converts it into a tile map so that we can use it. Now we're going to store our tiles in a variable, and this will be taking the information from the map, and we're going to say add tile set image. Pay attention to the camel casing. Tile set and image both have capital letters. And now with this, we're going to reference what image we're using for this. And we use the key that we established when we loaded the image up here inside the load image. So we said load image, we stored the key of Mario, and we then specified the path. Remember, then we were able to use that key to display it when we just displayed the image directly. Now we're using it to create our tile set image. Finally, what we need to do is we need to create the layer that we are going to look at. So this layer, which will use this level data, will be a static layer. And static layers render really, really fast in Phaser because it has that information and can store them. This is much better than, say, trying to create your entire world. So you could have like a 100,000 pixel wide image if you had a side scroller that was a long level. That would be brutal and no device could adequately render it. But using a tile set where it's just simple data, these numbers like this, and we're saying show this image here, this image there, it's very quick, it's very memory efficient, and frankly, it just works. Now we're going to create the static layer, and we're going to say what level it's going to be on, and then we'll say tiles, which is the previous variable up there, and then specify where we're putting it on screen, and we will register it at 0, 0. Now saving this document, I click over here and I will see that it loaded, and as it loaded, well, it gives me exactly what I typed in. Now I was just randomly choosing values in squares, so you can see the 0, 1, 0, 1, 0, 1, how that worked out to be. If I were to go back into my image and try and find something, so 0, 1, 2, 3, So 19, 20, 21, if we added 20 and 21 in somewhere, so if I said this would be right here, we'll go 20, call this one 21. Now let's save it and see what we have, and we can see how we grabbed a little bit of the greenery. So there's 21, so 38, 39, 40. Oh, I don't want to go there. So let's go put in, we'll make this 39, call this 40, save it, and let's see what we have going here. We get the top of the clouds, 39, 40, and adding in 58 and 59 corresponds to, that's now giving me my different cloud images so we can start to put them in. So as you can see, we're able to work with the tile map and start to build it in. Oh, this is 3 wide, so we need 2 more. So let's go. Oh, keep clicking on the wrong file here. Let's try 38, 57, and now we have the cloud. So we're able to use this tile map to put this in, and it works. Now, static layers, as we created this, a static layer, they are what we'll be using on this first project. We will eventually look at dynamic layers so we can add things even at runtime, and dynamic layers allow for more possibilities, more dynamic interactions, so they work pretty slick. But for the beginning part, we will start out with static layers because it will give us the most control and options. So this is a good beginning. It gives us a start. But trying to do all of our work here where we're looking at the map, trying to guess which items are there, is just not fun and will be frustrating more than anything else. What works better is to use a program like Tiled. We can find Tiled at mapeditor.org. So you can download it from here and use it. It is open source, so they do ask for donations, but it is free if you want to go with it and just use it. Now, when it comes to finding artwork, you can make all of your own artwork that we'll be using in Tiled, or you can download from Open Game Art or from Kenny. Both of these are fantastic resources that have lots of good things. So go under Assets. Right now we're working in 2D, so you go choose 2D assets and you can find what you want. Now if you grab something, you can always take it into, say, something like Photoshop and recolor it. So I started with the 1-bit pack for my artwork, grabbing it off of Kenny, added a little bit of color to it to stylize it more in the way that for the visual theme that I was looking for on this project. So as we look at it, we'll see that it has even letters and playing cards that we could use, little creature icons, weapon icons, walls and bridges, and foliage, and just all kinds of good fun. So we'll be able to make use of a number of these things as we explore some really basic introductory options working with the artwork in Tiled and building our tile maps. In Tiled, I'm going to create my project and I'm going to save it into my folder here. So I'm going to just save the project here so I know it's with this project, so it's part of it. So Tiled likes to know that you're working on a project, and now the first thing that we do inside this is create a new map. So right now my map is 25 by 20 tiles wide. This is mostly for demonstration purposes so that it doesn't take too long to draw the artwork. Our tile sizes our 16 by 16 as we're working with it. If I want to go bigger, I could. So we have a lot of options. Now we'll see that we can also choose our tile layer format. CSV works. So I'll choose Save As, and it's going to prompt me on where I want to save this. So I'll make sure I put the word map in this. So it's my purple map demo. And I want to save it into the same location. So this is going to be then part of the Phaser project. I could have all these in their own folder, but it all works. Now, when it comes up, we see there's my world waiting for me to put my tiles into the world. And the next thing that I need to do is I need to choose tile set. One key thing to pay attention to while we're doing this is under tile layer format, CSV is an option. We also see there's some compressed options and uncompressed. What's important is we either choose CSV or base64 and a compressed. If we choose the compressed options, they do not work properly with Phaser, so you've been warned. The next thing is to add our tile set. This will give us the tiles that we can then paint our world with. And with this, I will choose my... Now, I can provide a name. Actually, if I don't put a name there, it even works better. If I just choose Browse, and I go and find the item that I'm working with. So let's go into the project. I already have the graphic I'm going to use, which is in my tile map folder. Here's purple. I'll click Open, and we can see it automatically appended it right there, and it's ready to go. Now this map, I'm not working with transparency on it, so I don't want to choose transparent. And I have no spacing between the tiles. Some of the tile sets, when you download them from sources, they have a 1 pixel gap between each tile, which can be good or bad. Files are a little bit bigger, but it does prevent edge bleed between artwork, which can sometimes be an issue. So if you have that gap, that can be beneficial, because then as you're laying out your tile set, you don't get these little lines that sometimes show up. And other times having that gap causes lines to show up. So it's kind of damned if you do, damned if you don't. You just have to try and see what your project, your artwork, and your game engine do for you and how they work. Another important thing is to make sure that Embed in Map is selected. If it looks like this, that's not going to work. We need to make sure that that is embedded into it. That is going to give us the data when we write out our JSON file, the JavaScript object notation file that stores the information about our tile set and tile map on what's happening with layers, properties, what artwork to show in which square, etc. So then I can click OK. There's my artwork, and it's ready to go. Almost. Now, the next thing that I want to do as I set this up is I will want to create a couple of different layers, because we want to create a base layer. This will be our below the player layer. Then we will create our world layer, which has all of the obstacles that the player could collide with. So trees and buildings and fountains or signs or other things we don't want the player to walk through or on top of. And then we can even create an above layer, a layer that sits above the player, so it looks like the player is going partially behind or completely behind things. So it gives us a certain visual effect as we're doing it. So we can set up these different layers as we build our project. So I want to name this below layer, right? Below player. So we'll call this below player right there, and then I will add in another tile layer, and this will be my world layer, or we can just call it world. They both, work. And finally, we'll add another one, and this will be above player. And eventually you will notice that there are other options here, and we're even going to choose an object layer because then we can even put some other information in, like say the starting point for the player. We can have it planned out inside our map here as we work on it. Now as we start drawing our artwork, it's really important to make sure that we pay attention to which layer we're on. Well, I don't want to drag it up, I was trying to lock it. Good practice is to lock whatever layers you're not currently working on so you don't accidentally do something. Now if I grab a base color, so I'll just grab the solid purple, and this works like every other imaging program. Hey look, I have a paint bucket. Boom, there it is. Done. Now I've colored it in. Now we're going to go to the stamp tool, and this is where it starts to get more fun. So with the stamp tool, I am going to add some walls around my whole world here. So actually I don't want to do the walls on that layer. I want to add some roads. I forgot. I want the walls to be the perimeter here. The walls will actually be on the world layer, but we're not doing that yet. I want to just do the decorative pathways that are on the world. Now to make it easier, because we will need to figure out which layers are colliding and which layers are not, as we do this, what I want to do is to grab some of these tiles, and I'm just going to create some pathways, and then we will be setting things up for the players so that they can walk around the world. And now I'm going to grab, so I did that just with one tile. Now if I look here and go grab a different tile, now I'm going to, so we'll see how some of these tiles are set up. So I want it to be that these are the paths that the player can follow, build a little bit of random movement or coloring in, so it just seems visually a little bit better to work with. So I've now chosen a couple, and now we can even grab a little more variety within it, so we don't have kind of so much of the same. So we have those, and that now gives me the starting point for my world. So now I have some background artwork. Now this is all areas where this whole layer, currently the player can walk wherever they want. We'll use these paths as a guide of how to narrow it down. Moving up to the world layer, so I'll lock the path, go to the world layer. This is where I want to now put some walls in. So if I want to frame in the world, I'm going to use, I think, put in a corner here. And now the artwork, it gives me the four corners, but if I didn't have four corners, so say I had that piece right there, I have these controls up here. So I could rotate this, or I could flip it to try and align it. So it looks like if we rotate it like this and I go here, we can see how now it rotated that artwork. And that's, you know, I have four corners, so it's not a big deal. But if I was working instead on a project where I wanted to, say, use these pipe pieces, I don't have pipes in every direction, so I have to continually use the rotate and flip options to get them to line up in my project. So I'm adding in the different tiles. So remembering that when we create our tile set, the one option we have to remember to select is Embed and Map. If we do that, we're going to be in pretty good shape. All right, so now I can even in Tiled, I can go grab something like that square there. I can just highlight this whole chunk and set things up. Put one here. I'm going to put this one there. Put this here. And we'll put a companion one right here. Let's see, what else do we got? We'll grab that little guy right there. It's going to frame that part. And now, what's kind of nice is we put some of these things in. You can even go and grab. So that'd be 3 by 4. We'll notice how that fits in nicely right there. And now we'll go grab 2, 1. And looks like we still need a few. But I don't have to use only those. I could even stick that right there, this right there. So as you can see, we have a lot of options as we try to fill these things in and build. Oh, don't want a 3 wide. We want a 2 wide, so it corresponds with what is there. What I'm trying to do is to really kind of avoid any kind of really repetitive use of existing patterns, so I create a little more variety within it. Okay, I really don't like those that much, but we can go with it. And maybe we'll grab a couple creatures to put over here instead. So as we fill things in, we're going to be finding that we have different options available to us. And let's see, I want to, so I've set all of those in. So right now I'm only using purples. So I used these 4 squares down here in the bottom as my path, the upper purple as my core background. Now, what I also want to do is I want to set something up. So I'm going to put that red right there. And now if I go above the player, we're going to put that above the player right there. And we'll put a second copy of red right there. I'll grab, oh, those are the 3 I used before. We'll grab these 3 this time. All right. Oh, shoot. I don't want, I only wanted the top on that layer, so I don't want these here, so we'll get rid of that. Relock the top layer, go back to the world layer, and now this time with the world layer selected, we'll go grab some other items. So not those 3, but actually that kind of, so now we have those tops are on the world layer, and we'll see how that works when we're in game. And then we can see what's on the bottom. And we have our 3 layers configured in our project ready to go. So it's always a good idea. We can save this. Now, if you forget while you're working and you want to verify your map properties, you can select that and it pulls up the whole list on the side here, because once we're working, we'll notice those properties go away. So if we need access to them, that's what we need to do. The tile set, we now need to add an additional property to it. So down in the controls, we have this little option with the gear on it. I click on that, and now it opens up where we can see we have my TMX file, my tiled file, and it tells me the map I'm working with, which is purple. And what I'm going to do is I'm going to highlight everything, and we're going to add a custom property. The custom property I will add will be collides, and it's going to be a Boolean. So we'll see we have options on the list. So it defaults to string, but we want to use a Boolean. It's either going to collide or not collide. So now I can click OK here, and with everything selected, I'm just going to check that box. Now if I click on any one of these, we see how they're selected. Now these three squares don't collide anymore, so we'll turn them off. This top square up here, that's our main background, does not collide. We don't want it. These four that I used for my path, I don't want those to collide either. So we turn off collide form, so I can verify it and which ones have collide and don't have collide attached to them. And now I can save this. So this now allows me to store that information, and we'll be able to access that collision information in a little bit when we get back into VS Code and start adding this into our project. To add this into our project, what we need to do is we need to export it. So we have the graphic, and we need to create the JSON. This will be the data file that we can use inside VS Code to make it work. So I can choose export or export as. The first time we do it, we choose export or export as. It doesn't matter. Every other time, if we make a change or update, we just have to go under File, Export, and it updates the file, and then we're in good shape. Now with this, I'm going to put it into my script because it is going to be a JSON file. So we'll see it often defaults as all files, but I want to choose JSON as my starting file because that's what we'll work with. And we'll see we do have other options, CSVs, Luas, etc. But we want JSON here because we're now exporting it as a tiled option for it. Jump into VS Code, and we'll see here is the JSON. So we can see where it now put that information. So here is that level information that we worked with, where we're now coloring everything. So again, you would not want to write that by hand. We now have our layers, and then we have information about every square, every tile inside our tile map. So this is where we have all of that information, and we'll be able to work with it. So the next thing we're going to do is, instead of working on this Mario, we're going to start a fresh document and add in our tiled information. So with that, I can just go to the shell and copy that, go into scripts, paste, and this time we'll rename this one, and this is going to be my main. So this is the big one. This is when we're finally going to start making something real. I do need to remember to switch this now that I made the main.js, which was a copy of the shell. Switch index so that it points to that. Click over to the live server. We see we're back in the game over there. So now we're going to start populating it in main.js, and we need to load in our tile map image. So this is the tile map that we need to load in, and then we also need to load in the JSON file that we received out of tiled. So those two things will need to get put into the project. To do that, we simply use the this.load, and let's try again, load image. And this time we're going to first load the image, and we will name it tiles because it has all of the artwork for the tiles on it. We need to jump out of our folder we're in, go to Assets, Tile Map, and purple.png. Then we need to load the JSON. To pull this off, we go this.load.image, and actually it's not an image. It is a tile map, tiled JSON. And we will name this one map as our reference key, and then it will be, sorry, it's not an assets, I'm thinking ahead of myself. It's in our scripts folder, and this time it is purple map demo.json. And if we save this, we just check over here, and oh, purple Madden? No. Purple map demo. And verify the name. Yeah, that looks correct. Save that. And now we have no error messages. So it's useful if I can see the console area while I'm doing this. I can immediately see when I save, do I have error messages or not? And then that is going to help me out as we work with it. The next thing we need to do is start creating our level. This is going to be very similar to what we did in the Mario, where we have to make our map, our tiles, and our layer, except we have more than one layer that we'll be working with. So we can set up our map. Const tile set is equal to map.add tile set image. The image is the image we loaded, purple, and we're going to give it a name of purple, my bad. And we are loading the file reference of tiles. Now this purple that we put in here, well, notice it's not occurring anywhere inside my load statement. That is because purple is where we see the reference to the tiles that are associated with the map. So this is where we see purple happening. So whatever you name your tile set, that is then going to be the name that you are going to use when you are referencing it here. So this is the name of my tile set. This is my reference to the image that is being loaded. So that is a key item to keep in mind as we work with this. Now we have a few things we'll work with. Our below layer is going to be map.create static layer, and this is where we go back into tiled and we can check out our layer names, below player, world, and above player. And that is where we're going to be referencing those. So we have below player. Your capitalization is going to matter here. And then I am going to reference my tile set that I just put in the previous line of code. And then we're going to put it on screen at 0, 0. Const world layer. I want a cap in there to be consistent. It's equal to map dot create static layer. This is going to be world and tile set 0, 0. So we have one tile set here. It's entirely possible that we could be using multiple tile sets to generate our map. So if we loaded multiple tile sets in while we worked in tiled, we would load each of those as separate images, and we could reference those different tile sets and use those as we are building our artwork. It gets a little bit more messy when you do that. My advice would be to actually composite everything into a single graphic file and texture atlas if you are going to do it, because it will make things easier for you when you are doing so. So now this will be above player. Now when I name those layers inside tiled, I had spaces in the names, thus I need spaces in the names here to keep consistent. So this now creates all of my static layers. And when I hit run, we see we get an error message here. And if we read that, map is not defined, and then I go back up here and look and realize, oops, I forgot one line. So if we look into Mario and see the process that we used, we made a map object, our tile map. We have our tile set image that we are using, and then we create a layer where we tell map to use that image to make it. Well, we did our tiles and layers, but I realized now over on main, I forgot to create the map. Now, our creation of our tile map is going to be slightly different this time. There we go, tile map. And what we're going to do, there we go, curly braces, not square brackets. And now we set the key we're going to use, and our key will be map. So we create our key to use the tile map. Now if we're like, okay, where did that come from? Well, we can just look a couple lines above and we can see when we loaded the JSON, we referenced map. Now we're making a tile map with map, and then we tell map to add a tile set image, so using that graphic, purple. And then we are going to create our 3 layers. So let's save this and see what happens. No red shows up on the side, that's good. And got something happening. We got some artwork showing up. That's a good sign. Now, as we look at it, we can see that we have some interesting scaling issues happening there. And we can see, well, we set the game at 300 by 240. If we were to shrink this down, and I'll just do 800 by 600, so it's really big, then we should be able to see there's our whole map. So it does translate over. All 3 layers have indeed shown up. So we're in good shape. But I'm going to go back to the small view, because when we use that, we're going to then enable the camera. We'll position the player on screen, we'll use the camera, and then we can make our world navigate as a player character moves through the whole thing. Actually, I will go back. I do want to show one other thing first on it, and that is to allow us to see where our collision area is going to be and to set up the collision on it. So if we remember, when we created the world inside tiled, one thing that we did is we set it up so that it had a property called collides. So it's entirely possible inside Phaser that we can reference collision by tile ID number. So we can say by certain numbers which tiles are collidable and which ones are not. Now, if we have hundreds of tiles in our tile sheet, that's really going to suck. That would be a crappy way to do it, and that's why we set this property. So the property that we set is going to be collides, and then we want collision to happen. So world layer will set our collision by that. Now, we can't really see what's going on, so we're going to add some debug graphics into it so that we can better see where those collision areas are, those hot spots, so to speak. So I'm just going to we're just setting some properties up here, and so we're setting it so that we're going to overlay some graphics on the areas that are collidable, and we will just add solid color to it, but set that color's alpha to transparent. So we just have to set a few more properties in here. So I want to set the color that I am going to show for tiles that are collidable. We will make it yellow. And then we're going to set the edges of objects of their kind of bounding box or hitbox area to green, because then these colors are visible on top of our primarily bluish purple red background. So now let's save and see what we get. And we have a problem in line 56. Oh, it's not graphic, it's graphics, plural. Save there, no error. And now we can see it's showing yellow. Everywhere that is yellow will be a wall that the player can't move through. Everywhere that is not yellow will not be a wall. And we can also see that green edge showing up on these. And if I go back into this, if I change my size, look here so we can see even closer, so I can see that green edge occurring, those edges that are helping to decide our box collision on the graphics. So that gives us some guide as to what is happening with the graphics or with the collisions inside our world. With the tile maps rendering, it's time to add in a player so that we can set the camera to follow the player and move throughout our world and see the collisions happening. So I've made a graphic. So this was taken from a larger sprite sheet from opengameart.org and cut it down. So each one of these frames is 32 pixels by 32 pixels. So we will scale it once it's into 50%. So we'll set the scale on it. But we do need to look here, and so we can see that right now frames 0, 1, and 2 correspond to a downward movement. Frames 3, 4, 5 correspond to going left. 6, 7, 8 correspond to going right. And 9, 10, and 11 correspond to going up. Now, the nice part is once I tell Phaser the size of the frames, I don't have to have all of my artwork in one row. It just can count frames. It knows, oh, I hit the end of a row, I'll move down to the next one, move down to the next one, move down to the next one. So it works pretty slick that way. So the first thing we're going to have to do is we will have to add this character to our project. So this will be a load, and the load will be a sprite sheet. This is how, whoops, forget. It's all lowercase here. I'm going to call this my dude. And he is going to be in my assets folder. And then it will be dude.png. And then we need to specify our frame height or frame width, which is 32, comma, frame height, which is also 32. Then finally, I am going to create a reference to my player, so I'll say this dot player. And and of course, it does help to actually type in the word assets. I said it, and then my brain failed. So that's how I'm, again, checking the error message over here so I can see what is showing up while I do it. That makes it easier when I'm coding. That's where the live server is super, super handy because it allows us to work on this. Now, going back into Create, let's add some stuff on the player here. This dot player, it's going to be this dot physics dot add sprite, and I'm just going to guess at a location right now because I don't know exactly where I want it, but we will figure it out. So remembering that he is, where's my load? There it is. Oh, sorry, not dude. There we go. So he's going to be my dude then as I put him into my project here. Dude, guy. We can call it whichever we want, but we will put it in as part of the project. So now with that added into it, and as I said before, we'll scale it so the player is now the size of a single tile. So the artwork is 32 per frame. My tiles are 16 per tile. So it makes more sense to shrink him down so he kind of matches. Otherwise, it's going to have a hard time fitting through doors. Now we need to create some animations to go with this. And once we have one, we'll do some serious copy pasting. We just have to make sure we change things appropriately. So this is going to be the same kind of thing that we did in the demo game. Now, I know that it's for left is going to be 3 to 5, because if we go back here, 0, 1, 2, 3, 4, 5 are those frames. So that's where I'm getting those numbers from when I do it. And we can set our frame rate. We can always adjust that if we determine it is not the ideal frame rate for what we are trying to do. So that now creates one of the animations that we are going to need for our sprite. So copy that, paste, 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 paste. So we have left, right, up, and finally down. So down was 0 through 2. Up is going to be 9 through 11. And then right is going to be 6, frame 7, and frame 8. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So those are now the 4 frames that we need. We have left, right, up, and down as part of it, so that's good. So we're making progress here. Now, the next thing that we can do will be to say this dot player dot set collide world bounds true. So these are things that we've done before. This dot physics dot add collider. So we're adding a collider between this dot player and the world layer. Now you'll notice I didn't put this in front of it because we set the world layer as a constant. So as a constant, we don't have to use this when we add it to it. And now finally, this dot cameras main start follow this dot player true 0.8 comma 0.8. That just adds a little bit of easing into the movement of the camera. All right, so we're in good shape so far. Now we need to set some things here, and to do that, I'm going to store my speed in a variable, and then when I do that, then when I set the velocity, and we set it on the body of it, that gives us a little bit more control. So velocity x, when we go left, will be negative speed. So by using a variable for the speed, it makes it super easy. If I decide it's too fast or too slow, I change it in one place, and I don't have to change it 4 times. So that makes my life a whole lot easier. Set velocity y. So if we're going up, it's a negative speed. And this dot player dot body dot set velocity y. This time it will be speed. Now we're separating out movement from animations because we're going to realize as we do this we will need a little bit more control. So we will put the animations into it. If I save this, let's see, there's no red that showed up there. There's a player. Oh, I just loaded the wrong graphic. So, oh, I want a guy, not dude. Dude was from the previous example. So I'm going to, I could change it in there, but I'm going to Alt click or Option click everywhere I said dude. And let's see, and once more up here. And right here. Now let me look and say, hey, look, there's my guys sitting on top. Now we have the, whoa, look at that. So, hey, we have some colliding going on. Whoa. That, okay, now you can see we have some layer issues going on because I want the roof on these 2 buildings to be above the player, but it's not. So we're going to have to address that, and we're going to have to address the movement here of the player. And it looks like we have some world bounding issues going on as well, so we will have to figure out how to fix that. But it's kind of cool how things are working. Now that's not a lightsaber or laser beam. What we are seeing, because we have debug turned on, then it shows us what his velocity is as he is moving. So all right, so now I see the correct guy. We aren't seeing the animations yet because we didn't tell them to start playing. That's good. And I'm going to move the player up spawn position here a little bit. We'll just say 130. All right, that's better. I like that. So now it's appearing in the right place, approximately. It's not quite showing me the right frame that I want to start with, so we will have to take care of that in a moment. But we have a few other, I would argue, slightly more pressing things happening. Now, as our different layers have been added into the world here, we need to set the physics of the world. We probably also need to adjust some depth issues happening to these layers, because otherwise all of these layers exist. Then we added the player on top of that, which is why the player sits above it. But if I say above layer, set depth, and we can just say 10, or I could even say 100 or something like that. Now if I look what happens, we can see the player is behind that kind of roof of that building. It doesn't quite look like a roof when we have the yellow on top, but we do see more of it when we adjust it. So that's good. So that depth sets it up. As long as we declare that in create after we've named those variables, then we're in good shape with that. What we now need to do is we will need to set kind of the physics of the world and establish that. We have the camera. Since we're using physics and collider and all of that stuff down here, I think it makes sense to put it in this place. So physics, world, bounds, width is equal to 400. This dot physics dot world, not width, world dot bounds height is going to be equal to 320. So that's the actual size of my game, 400 by 320, as I established when I created it inside of Tiled. So let's see if anything different is happening now. And now we can see it's working. Now we also have some other things because, well, the player stays centered, but I really don't want to see all that kind of background. I mean, maybe I do. Maybe I want the player always to be in the dead center of the screen because we're using follow, and I don't want, so I don't mind seeing the extra border around on the screen. But if I do mind that, then we need to adjust what is happening with the camera. So the camera is following the players, but before we do that, we may want to set the camera, this dot cameras dot main, because we're just using the main camera right now, set our bounds for the camera to be 0, 0, 400, 320. Now you may notice we've said 400, 320, 400, 320 in two places here. That's a pretty strong indication we would ideally want to store those in a variable object so that we have access to them. So realistically, we want to start thinking about trying to access these values as part of our config so that we can work with it. But now if I notice, as I move over, we can see that the world doesn't extend over. So as we're playing around with cameras, those are some of the things to keep in mind. Is when we set these properties, if we don't set the bounds for the physics or the bounds for the camera, then we do start getting some weird things happening. The physics one is really important. The camera one, well, you could have different artwork in the background, so the player is always centered and it just kind of looks like, well, that's our window. That's fine. It's entirely kind of up to you as to how you want to take care of that. Now what we could do here is inside this, if I go this dot player dot body dot set velocity, and we're just doing full velocity, not x or y, but if I set that velocity at 0, now we'll see I stop pressing the button and it stops. And you can, it's kind of cool how we're able to go behind things. So we can set up an above layer. In yours, I would expect something more complex. So you could be going like under, like through a doorway, through an arch or something. You can have that on top. You can have all of this layer below. So there's a lot of options. So we're doing better with it. Now it's time to show some animations here and set those up into our project. So we need to say what animation we want to say. So this dot player dot anims dot play, and we'll go up, true. So we'll just copy that. Paste, 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 paste. So now we have a couple of different things going on. So we have up first, then down, and then left, right, and so in our animations we have a bunch of if else ifs, and we finally end with an else, and the else that we're going to end with is not going to tell an animation to play, it's going to tell our animations to stop. So let's see what happens here. All right. One thing that we can do to make this a little bit easier to see, let's just turn off debug there. And I'm also going to go find my debug graphics here. We'll just set this at 0. Goes away. Hey, look at that. So now we can see how he's walking. This also is helping you to see that perhaps we need transparent graphics. And this particular graphic set included both opaque and transparent. So if I loaded a separate image or extended the tile sheet to include both, I could have then had transparent images in addition to the opaque ones. But we can see players moving, but we do have a bad thing happen on diagonals because we're now able to effectively achieve multiplied speed. So that's just a little thing that we want to address on that. And it's pretty straightforward on how we can do it. So we have the movement happening, we have the animations happening, and what we can do now that we've kind of separated those two things out, so we can tell the player velocity that we want to normalize it. And then we are going to multiply it by the speed. So what normalize does is, when we had debug on, you saw how the green arrow when we went diagonally got twice as long because we had the speed horizontal and the speed vertical. Because what it's doing with the speeds when we're using velocity, it's using a vector. So that's a math construct. A vector is something where we have an angle and we have magnitude, how long it is. And with that, when we add those two vectors together, we get a faster speed. So we need to normalize it, which means we scale it down to, we figure out whatever direction it is, but then we make it essentially 1 unit long, and then we multiply it by the speed. So then that allows us to have the correct angle, but our speed then is never going to be that extra fast movement when we're in a diagonal direction. So if we look at it now, oh, hang on, got a little typo in here. So this dot player dot velocity normalize, oh, sorry, not speed, scale. We're scaling that vector. So we normalize takes our vector, which is magnitude, how long it is, and angle. It keeps the angle, but it makes the magnitude 1. That's what normalize does. But then we're scaling this by our speed value, which is 100. So then we're moving at that correct amount. Now, when I move diagonally, it's not going double fast. The other option is you make it so we can only be moving in one direction at a time, because if you notice, we have these separated out. So if we go left, right, else if up, down, else if up, or yeah, we have up, or else if up, up, else if down. If we do it that way, that favors left and right, so we'll generally be moving left or right first, which in this kind of top-down map usually is what you want, but it does prevent diagonal movement. So you have to let go of a key and press a new key, let go of a key, press a new key to get it to work properly. So that is another thing that we can do with it. So now when we look at it, now the problem sometimes is we're not ending on the frame that we want to, and there's a couple of different ways that we can go about solving that, because I don't like where it sometimes ends mid-walk. So we want to be able to say which frame we want to see. So we can notice that the player, when we look at it, is in kind of a walking position to start, but that doesn't really make sense, because when we look at the player, we really want to be using frame 1, not frame 0 as our starting frame. So there's a way that we can go about doing this. So one way that we can do it is we can use this dot player, and we can set which frame we're aiming for. Noticing that we'll be aiming for frame 1, 0, 1, 2, 3. We'll want 4, and then so 1, 4, 7, and 10. Those will be the 4 frames that we're going to be aiming for as we do this. So right now, this sets the frame of the player so that when we look at our game, we can see we're now on that. If I were to put in something like 10, we would see that we now have an option like that. So we want frame 1, that gets the player starting in our standard kind of top-down explore the world style game. So that gives us a good start here. Now what we want to do is we want to figure out, when we're done moving, how we can, so when we're no longer holding down a key, how we can stop that animation, send it to that kind of idle frame. And we're going to do that by checking the velocity of our characters. So we need to store, because remembering at the beginning of each frame we're killing the velocity. So before we kill that velocity and then add in more each time, what we want to do is previous. So previous velocity will be equal to this dot player dot body dot velocity, and we are going to grab a copy of it. So we say clone. So that now gives us a copy of that, so we have access to it. So after we're done moving, what we are going to do, so then we can set our idle animations, but we set these idle animations only if we're not moving. So we say if this dot player dot body dot velocity dot x is equal to 0, so completely equal, that's why we use the triple equal sign, and not or, and this dot player dot body dot velocity dot y. So we're looking at the y component, and if that is also equal to 0, then, and only then, now we want to show idle animations. So if player velocity, the x component of it is less than 0, which means we're moving left, then what we can do is say this dot player dot so we're going to use that set frame notation here. So this dot player dot set frame. So if we're moving left, looking over here, left 1 2 0 1 2 3 4. So we're looking for frame 4. Set frame 4. Now else if previous velocity dot x is greater than 0, that must mean we are moving to the right. So this dot player dot set frame, this should be 7, I believe, because 7 is the next. And then once more, else if previous velocity dot y is less than 0, that means we are moving up. So this player, and it's nice if you type player, it automatically adds this into it for you because it knows that it's that context. And frame, and this time, so if we're moving up, this is going to be frame 10. And then finally, else if previous velocity dot y is less than, or sorry, greater than 0. Now we have less than, greater than 0. And now with it greater than 0, it'd be player dot set frame. And this time when we're setting our frame, because we want to be 1, because that means we are moving in a downward position. So let's save it. And we have at line 161, player, and I look here. So player velocity is not defined. It is previous velocity that we need, so we can save that. No error messages. Good. Now if I click here, let's see, and it ends, and no matter what I do, if I just kind of tap it, we can see how it keeps going. Moves down, moves up. So no matter what I do, it's always going to be moving it and ending on the correct idle frame. So there's lots of ways that we can go about solving this. This seemed to be a straightforward and direct way to solve it. So to recap here, we have our player. It's moving. It can't go past objects. Can't go past the walls. The camera is following it. And now let's see, we have a wall here. Move over, but now we hit the world bound, so we can't leave it. Now you could, if you turned off the collide with world bounds on it. Now, looks like the player's exactly 16, the world is 16. Sometimes we want our players to be smaller than the world, because that's making it a little bit challenging to get it to fit in those doors. So we might want to try something like 0.4 and see. Now the artwork didn't scale beautifully, but it's now going to be a little bit easier to fit your way through. So then that helps out as we are trying to build the world. So we've looked at using tiled, we've looked at bringing back cameras in, creating a large scrollable world using the camera following. So I'm going to go back to 0.5 because that really didn't scale well. So I probably want to scale it in a graphics program and not scale it through code. That's going to give me a little better result as we do it, especially if we were to shrink everything down on the world. So with that, I think we have a pretty good start on putting together a game. Now the next part would be to figure out what else happens in the game during the update. So if we have pickup objects that we're running into, what happens when we get those? If we have enemies that are chasing after us or that we can run into them and that causes an encounter. When that encounter happens, what is going to occur? Do we switch to a new scene and provide text? Do we do an overlay? We make something show up on screen? Because we have a lot of possibilities how we can continue forward with this. This is just the first step.